Now that we've looked at rooted trees, we're going to do a variant of rooted trees called binary trees. But before you look at the rest of the video, I strongly encourage you to at least start looking at the problems in the in-class activities called binary trees, just to get an idea of what the process of creating binary trees is like. It'll make this video make a lot more sense. You don't have to finish it, just do a little bit of that process. Okay, so in this video, we're going to look at the definition and construction of binary trees. We're going to give a formal definition, which happens to be a recursive definition. And then we're going to generate some examples. So binary trees have the following properties. So first of all, they are rooted trees. And then we had to determine for each child of a vertex whether it is considered to be on the left or right side of its parent. So not only do we care about what the generations are, but whether it is a left vertex or a right vertex. And the definition is recursive, which means that every time we make a new binary tree, we make it out of old binary trees. So we take a new vertex, which gets to be the root, and then we make the rest of the tree out of two previously defined binary trees. So here's the formal definition. A binary tree is a rooted tree that's defined recursively as follows. First of all, the empty tree, which we haven't encountered before. It's not super interesting. It has no vertices and no edges. That is considered to be a binary tree. Every other binary tree is constructed by taking a vertex and connecting it with an edge, making it the root and connecting it with an edge, if that is possible, to the roots of two other binary trees, one on the left and one on the right. And I do want to note that that includes connecting it with an edge, if possible, to the empty tree. And if it happens to be you want the empty tree on the left or right, that means you just have nothing on the left or nothing on the right because there are no vertices to connect your edge to. And we'll see how that works in the varying levels. So we're going to do this in levels. First of all we have at level 0 is just the empty tree. And so I'll denote that by the empty set because I can't draw it because there's nothing to draw. I can't draw any vertices, can't draw any edges because there aren't any. Now at level 1, what we're going to do is we're going to have a vertex that is the root. There you see the root. And then the only ones we have to connect on the left and right is we have an empty tree to put on the left, empty tree to put on the right. And so I did it. You didn't see it because of course there are no vertices and no edges to add. And so all you get is a vertex with no edges. So that's a level 1. So again, we went from one graph to one additional graph, adding it at level 1. Now at level 2, it gets a little bit more exciting because we start with a root and we can add on the left or right either an empty tree or our level 1 tree. So for instance, we get 3 different binary trees. So the first one, just to let you know, is you have a root at the top, and on the left you put a level 1 tree, so you connect that root, right? And then on the right you have a level 0 tree, the empty tree. And you have nothing there because it's an empty tree on the right. And for the second one, you have an empty tree on the left and the level 1 tree on the right. Now, notice that those first two are completely isomorphic as graphs, and they're completely isomorphic as rooted trees as well. They have the same root and they have the same structure. But as binary trees, they're different because they have different trees that they're connected to on the left and the right. And then the third binary tree is you take your root and then you connect on the left and the right to level 1 trees. Now notice that we are certainly allowed to connect to the same tree on the left and right as we did with that third level 2 binary tree. So it looks like at each level we are not adding too many new binary trees, but it turns out at level 3 this kind of explodes. So at level 1 we just had one graph, or level 0. Level 1 we had one new graph. Level 2 we had 3 new graphs. At level 3 we get a ton. So for instance, this first one is I take my root at the top and I put one of my level 2 graphs on the left. That's the one that you have on the left there, and then an empty tree on the right. Or I can put a different level 2 graph on the left and another empty tree on the right. That's fine for the second one. I could put a level 1, level 0, an empty tree on the left and a level 2 graph on the right. That's what I've done with these two. And these two, I put a level 2 graph on the left and a level 1 graph on the right. And we can just keep on going. Here's one with two different ones with a level 1 graph on the left, a level 2 graph on the right. Here are some binary trees with a level 2 graph on the left and the right. And then down here, I have a level 1 graph on the left, a level 2 graph on the right, actually just a whole bunch of various ones that are binary trees. So notice that on level 1 and level 2, we weren't adding very many new binary trees, but on level 3, it explodes. And you can imagine that on level 4, it would be even more explosive. There is no way I'm going to label all those here, but the basic idea is the same. Every time you go from one level to the next, you have a root that you put on top, a lower level one on the left, a lower level one on the right, and that gives you a new binary tree. So now that you got the idea about how to construct these things, I think you're ready to work on the in-class activities. It's called binary trees, and it is included with this video.